All right, we are getting started again. Here I'm working on the bin dash API iteration. This is what I've been doing all week. Bin dash hasn't been building all week as I've been working on refactoring, redesign, stepping up, iterating, moving forward on the design of this API. So off stream, I made some progress on starting up an outline of the API. I think I've got a lot of it. Where is it? It's not here. It's in bin viz, isn't it? Yeah, I've got a lot of it written down somewhere. Where are these defined? There it is. All right, this is the old one. Here's the new one. Right. Okay. So the question is, row, add link. Why is that not compiling? Right, so I was trying to decide, last thing I was working on is I was trying to decide if I should force you to modify rows by passing a row pointer right here and then going like row equals. The advantage to this is if I ever want to have these things get added after the fact, I can do that. I'm still requiring that the cells come out in order, so maybe it shouldn't be that big a deal to just say that this needs to be implicit, though. I don't know. It's a tough call. Maybe the whole API should be without any constructor state. I don't really know. I'm gonna maybe do it this way. So I'm gonna just be hanging out today, working on getting this new stuff to build. I'm gonna put on some installing Spotify. No. Yeah, no. Just open it. Yes. Okay, there we go. Something. Not too distracting, but with a little drive. A little video game soundtrack should work. Okay. Uh, Okay, we want to get to the point where we can use that. That's not going to be so easy. So let's focus on just getting this parser into even better condition first. Oh, okay. Cool. Nice. It's a little early, but I'm on a unusual time today. I'm gonna go take a quick break. Uh, All right, let's see. Paging Turner, let me tell you a little bit about the system. So the way I've built this so far is that I add a bunch of marks to the raw binary. A mark itself contains this stuff, so a range, a label, plus some stuff equipped to it. Right now that can just be like table data structures. And then there should actually be more in here, I guess. I didn't fully build it out. But the idea is you'd have like pointer first, OPL, and possibly size as well. All of these might end up being more like BV, submark, pointer, and submark size, or something like that. Who knows exactly how I will want to structure that. But what they do is when I have a range that I parse out of a binary file, if I want to say something like, oh, how did I find the beginning of this range? Was it this, like, was there a pointer to this from somewhere else in the file? Then I want to be able to highlight that pointer somehow as being the method for discovering this range from somewhere else, right? Like if I have a header with a pointer to the section table, then that pointer, or the file offset, is the my mic noise gate? I don't think I touched my mic. Is something different? Is it like noisy today? I think the big difference is I didn't put up my sound damping curtains, so if you can hear a lot of outside noise, that's probably why. I didn't change anything directly on the mic, though, as far as I know. Yeah, so the big idea is that I can mark something, like if it's an array, I can mark the pointer and the counter, like the count, to tell me the size of that array, or if it's a data block, the pointer and the size. So when I'm looking at a block, I can see, like, say I'm looking at malformed data. I'm like, why is this thing all off? Well, maybe the pointer is encoded incorrectly. And I'll be able to figure that out by looking at the block and be like, why is this garbage? And you look at the pointer itself and you go, you know what? I think this was meant to point somewhere else, right? The bug is actually where in the pointer data in the header, not in the data block that looks busted. Now, how I should go about structuring the constructor for that, I'm unsure. Right now, before you create a mark, you call these extra things that sort of queue up extra parameters for the new mark. That might not be the best way to do it. But you're not the first person to say that. If you want the true answer, I'm currently listening to the Fury soundtrack. But let's take a look here. No, I can't quite program it to that heavy. Let's see. Where did I leave off? Okay, I don't really want to have 6 copies of that sitting around. And I haven't even... Yeah. Would love a way to consolidate these down to you. Got to come back to that. Okay, I think I could do this best with macro helpers, so... like this. There we go. Okay, so if we want to consolidate these, this is like... this with a... Hmm. Cool. All right, now we have to allocate some cells here. Like that. Last row we added cells plus cell index increment. Okay. So that's the implementation for the new API. And it looks like everything's building. Obviously, I haven't tested any of it yet, and I haven't finished the baker that turns the construction version of the data structure into a, optimized, baked and packed version of the data structure. So it's not like that's everything that needs to be done. But as I was working on it, some other concerns started to become obvious to me. The worst of which is I wrote the API. I first designed it. Let me show you why I did this way. With a lot of pointer arithmetic in the plan. So like when I hit a mark, I don't give it an offset. I give it a pointer. And then I can do pointer and that pointer plus 1. So if I have like a pointer to a header, this gives me the range. And if I have a pointer to like an array, like the section header table, for instance, although I guess, oh, that's a warning. Yeah, section headers and section header count. So you can see I'm using pointer arithmetic to mark up ranges here. And the central plan is like those pointers have to be pointers into the original file block. Right, you get past this data, you get past that to the constructor here. And as long as you're giving it pointers that either that fit within the range inclusive from the beginning to the end of this block here, then they're valid. But there are places here and there where I know that I was actually counting on it to go past the end. Like right here. I actually want to be able to create marks that go past the end of the file. Because sometimes I am trying to mark that like, hey, a thing with 100 bytes was supposed to go right here, but the last 50 bytes won't fit. So I have an issue now, which is my API expects these pointers that technically are undefined behavior. They go past the end of the data block. And pointer arithmetic isn't defined outside of memory, although it always does what it's supposed to do, so I could kind of try to rely on that being right, or I could see what this API feels like if I were to be more heavy-handed about only doing file offsets. The advantage to only doing file offsets is then these would never be undefined behavior. There'd always be a way to specify any range, including ranges outside of the file. The downside is things like this convenient pointer arithmetic would stop working. I'd have to write this block like this without pointer arithmetic. So you see all of the spots where I'm setting up the pointer, I actually am setting an offset, and all the spots where that offset needs to be turned into a range, I can't use pointer arithmetic on a struct. I have to use a size of on the thing. And then finally there's this. Now like this obviously is not as convenient to type in, but I could clean it up. I could go let's see, one step at a time here. I could go cough f off. That's cough f off putter. So then of course cough f off is cough f off putter. Ugh, okay, right, and this gets even worse. So like, sure, I could do it here, but what about right here? This pointer thing I'm trying to do. I've grabbed a pointer off the DOS header. Now I have to go back, find the address of the DOS header, find the offset to the, yeah. It's members on structs and stuff like that. Being able to do this on pointer arithmetic just really helps for things like, hey, we pulled this DOS header out of the file. We know this is a file pointer, right? If we had a language that was specifically for this, you know, instead of marking it up as const, we might mark this up as like, this is a file putter, right? And then you'd go, okay, that makes this a file putter. This file putter here allows us to mark this as a file putter, and now file putters can go in here, et cetera, right? You could imagine all the extra layer of check we could have if we did that. I mean, we could try to use const in that way if we wanted. It would be a lot of extra typing to get there. No, I don't really like that plan. The thing I would want to be able to do if I had the file pointer type defined there is to redefine the boundaries of pointer arithmetic around that concept, so that things like incrementing past the end wouldn't be considered a problem. But it makes such a significant convenience difference to have it like this. I do want to fix up some of the naming here, because some of this I got more particular about later on. Got like a better consistent naming scheme. So anywhere, okay, right here when I'm marking the pointer, we'll use that. Cough, F off, goes there. I guess we only have those spots, right? If I'm not doing that, then that just goes like that. PE signature is that piece. And we're just going to have to trust pointer arithmetic's undefined behavior at the edge to not actually do anything besides the perfectly expected normal thing. All right, so to answer some questions from chat, the sim comp time macro, this is my base layer sort of namespace macro for static, essentially. I mean, like literally, it's defining static there. But it's part of a series. I've got a couple of these. So compile time means we link the macro, or we link the function. We resolve the function at compile time. There's also the idea of a link time and runtime symbols. So link time symbols are symbols that go through the linker. So like two object files that want to talk to each other across a linker boundary would mark their symbols as link time. And then there's runtime for like loading symbols out of a DLL. The point is, at what time does the symbol get paired off? So that, you know, symbol pairing is the process of making reference locations point to the correct definition, and so comp time is just a compile time resolved symbol reference. It's a symbol that when it gets referenced gets resolved at compile time. That's the idea. File offset. Okay. So I don't know. That seems to suggest to me that I need to rethink the implementation part a little bit, because the switch off of pointer arithmetic just feels, especially when I think about like this guy right here, right? Because this is using the address of a field from another. It's using the address of a field from another file pointer, and the equivalent to that right here is bv mark pointer f. If I did this without pointer arithmetic, I would need to find the DOS header offset, which, you know, in this case it's just hard-coded 0, so it'd be like 0 plus offset of member PE DOS header cough file offset, and, you know, even if I'm not required to remember the base address, that is a lot, right? And you see the difference between these two APIs and how annoying it would be to work with one and not the other. Like, that's just a big difference. So I think We'll hope for a pointer arithmetic undefined behavior to never become a problem and move on. But that means that the implementation I chose is a little off, because I was constantly clamping pointers to being valid. Let's check this stuff again. Yes, for test it makes sense. Okay. Okay, succeed as often as possible is the new goal. Even if it means giving pointers past the end of the range, just succeed as often as possible. That one I think has to be like that. Succeed as often as possible. In this one case, I will do a check, which is pointers less than data are not safe. Okay. But it always succeeds, just clamps. Okay. So, what else can I look at here? So the point is, yes, I want to be able to produce marks that have ranges that go outside of the actual data, because marks don't just mark up actual data, they mark up warning messages and errors as well, right? Or as I call them, stops, reasons why the parsing stopped going down a particular direction. So I want to be able to say something like, stop right here because we expected to find a full DOS header and it just doesn't fit. Although this one doesn't actually say that, does it? It says OPL. Most of them I was consistent about this. The early ones, as always, get a little bit differently constructed. So there we go. Here's one where I did it with pointer arithmetic, right? Now what I could do is say that I never actually rely on the pointer arithmetic in the API to handle undefined behaviors or bounds checks. Because like right here I'm being goofy, I'm being weird. I'm taking a PE signature pointer first and then checking if it's valid. I don't necessarily have to do things that way. So let's say, for instance, I could do DOS header, boom, test, DOS header +1, putter, and then DOS header +1. So now I can say like, okay, that's good. Now the DOS header itself, I mean, I don't technically need to do this. I should be checking DOS header good at every step anyways, so I don't care. You can see there are places where I was inconsistent about this idea of whether or not I take the pointer before I test. And it would be convenient for the parser writer to be able to just do this. Take a pointer to a thing, test if the whole thing is available, and then if not, mark it. If it is, mark it without a stop, right? Mark it with an error versus mark. Now, the point is, yes, if I want to go and do data visualizations on these, then someone else has to check that these ranges are valid. These are just markups. Someone else using the data will still have to validate that they are, they're not guaranteed to be valid markups, so someone else has to validate them as they're being used. And if they're not inside the range, it doesn't mean they're not useful to render, right? There could still be a good, like, the whole point here is to be able to mark a range that is useful information. This is wrong. This should be magic and magic +1 with a size pointer, or with a mark size O header size putter. Yeah, some of this early stuff wasn't written with quite the same plan as the later stuff. You see how pointer arithmetic lets everything fit so much easier? Like, that's hard to let go of. It's a little different. Hello, Mr. Double Rainbow. I'm happy to help you out in any way that doesn't involve me lying. I also don't know you, so consider that. I've never made a resume, so also consider that. I'm not exactly the kind of person that you want as a character reference. What kind of work are you looking to get into that you need to fill a gap in your resume? I've never made a resume because I've only ever applied for one job, and it was when I was in college. And it was the interview was by another student, so I like an older student, but like I didn't really care to impress. This is 4Coder. I'm using 4Coder to write my code. For Coder Discord if you want info. Itch version if you want to download a binary and try it out. But I got all of my jobs. I got all of my jobs based on people noticing side projects and offering me jobs. So, you know, you don't need to fill a gap in your resume if you're working for the people who don't check that kind of thing. Yep. Yeah, it's 4Coder. It's not 4Coder Friday, but it's Friday, so 4Coder's got to be on the conversation a little bit. So let's see. Where's the I'm not really finding any obvious things popping up about what I could do next. Like obviously I haven't actually finished parsing everything that PE files contain. I've done exports. But we could come up here and look and see like, okay, we got imports. We could work on parsing out the imports. Oh, my code is not at all a problem. But if you have opinions, I'd be happy to hear more specifically what you think should change. But I will defend this quite vigorously. I think my code is fucking awesome. Alright, let's see. I guess let's get started on, let's wrap up the stream with a little bit of time parsing out the imports here. Ooh, did I get an internet hiccup? Okay, video stream looks fine. Let me reload the chat though. Alright, what are we doing here? We gotta start with the data directory like we did with exports. Let's try that. Yes, I did go to school for computer science for a few years, but I didn't finish. Kind of a scam, in my estimation. Yeah, I know, right? Right? Okay, so the imports tables are a little more complicated here. Okay. Okay, we're gonna look through each of these. How are we gonna get those import directories? That's gonna be a cast off of BV putter BV. Do I want to mark the range, the subrange here? Or how did I do this with exports? I want to go check that now. Right, so I use the mark, which I already have, to clamp in that range there. Grab the... You can see here's another example of me doing this thing. So I think the way I'd like to do this is I'll stick import dir plus equals 1 there. And then use the subrange mechanism to make this easier. Imports, grabs the imports table there. I'm going to look at each one, and the point is, But if the lookup table v-off is 0, I'm done. Import dir. Do we have any place where we calculate the count? How do we... Oh, I guess there's probably a linked list of these, isn't there? Like we go SLLQ push somewhere in here. Import table first, import table last, import table count. There it is, yeah. Okay. Max count, iterating. If we find one of those, then break. For each import table. Now, what do we put in each import table? A timestamp, first forwarder index, a name. Then we read off that v off. Until we find a 0. Man, they're null terminated on both. That's a little spicier. Try using the PE format stuff to see if we can get a little bit of... There we go, some comments. Question, how much time have you been coding? Do you mean like for how long in my life or how long today? I'm at close to 2 hours today. I've probably been coding for close to 18 years. Maybe 17, something like that. Okay, what did we put in the tables for imports? That's the other thing I want to ask about here. Module, timestamp, name, ordinal. Right, so... Damn, that's crazy. Those Linux commands look ridiculous, and they are ridiculous. Okay, so the reason I'm stalling here, the reason I haven't made a lot of progress is this table's a little funky, and it does raise certain questions about what it means to visualize arbitrary data structures through a reusable visualizer. Right now, all I support is a table type. And so I could either make each import table have its own table, and they'd all have a name and an ordinal column. But what I ended up doing was saying, okay, well, we know each module has its own table, but let's just make one combined table with a module info column to go with it. I'm working on bin dash, by the way. Someone's asking. It's probably not going to do... Yeah, it's just not going to do anything right now because it's not... It's halfway through this massive rebuild, so can't show it off. Binary file visualizer, plenty of info on previous stages of it. So what you kind of want here, let me go over to Scratch. Like the true structure of this is that there's like a table of tables. So you have like your module column, a timestamp column. What else goes into that? There's the module name, there's the timestamp, there's first forwarder. Something like that. Let's see, what else did we have? Maybe you want the, right, and so then you'd have like, you know, kernel 32 DLL living right here. Right, your table would start to take shape like this. Maybe it's got no timestamp, it's got no forwarder at first forwarder. But then what happens is like, it shifts. There's this secondary table that lives under this one. This one row, right? And like, how do you structure that out? So then what you have is, symbol, ordinal, and you get like virtual alloc 1001 or whatever, right? You get stuff like this as the subtable thing. This is the table that lives as a and you could imagine it would actually be interesting instead of broken like this. But right, whatever. And then there's another one, right? So there's one of these living down here being like, oh, great, I'm user 32 DLL and I give you create window or whatever. Oops. I don't know what a good visualization for a structure like this is, where you have each row of the outer table contains within it a reference to an entire table, but those tables are all the same structure. So the way I had done this before was to just put a symbol and ordinal column right here, and then duplicate this so you'd have virtual alloc 1001 2 4 3 right, and boom, there's your solution. Now you just line things up this way and you have this get duplicated. I suppose another option here would be to create some kind of concept of like columns that are spanning subgranularities. So like these are all marked as going together somehow. This is like sub to that, right? And create window 555, destroy window 556. Right. And the reason this would be better is because now these cells, like this is 1, 2, 3 cells of the table, and this is 1, 2, 3, 4, 8 cells over here. These 3 cells could link to the import directory table, and each of these could link to their spots in the subarrays. So the question then is, how do you structure a data structure for this? Like, what is this data structure? Is it something I want to design? Is this what I need to do next? Is design a more flexible hierarchical table type where there's this concept of sort of merging cells together and equipping them with links? Is this really multiple? Is this tables inside tables? Would this be like if I had the ability to take any row? Let's say one way I could structure this. Okay, there is one obvious way to structure this that popped into my mind just now, which is I could take any row and just say, in addition to all of that, each row can have its own subtable. Because then what I can do is I can create a row, put down this column, and this column. But the only problem is these columns kind of are being displayed as if they're shared here. And so these tables would not be free to have separate columns. We could create column groupings somehow. So let me try to think of like what the code would look like to generate something like this. Let's work on it from that angle. No, that's not the right music for this kind of problem. There we go. Let's see. Bad Nintendo saying something in chat that is maybe an idea about how to structure this. If not index 1 equals data endpoint, if starting point 1, else if... I don't know what you're talking about. Yeah, your pseudocode doesn't translate to anything for me. Let's do this. I'm trying to figure out how to structure this. So let's do... do a little sketching here. It's going to be like, we make one of those. Now we have these column groups. All right, so BV table, column, table, symbol, ordinal. Yeah, paging. I'm wondering if it's like the time of day that I chose today. I've been playing with the time of day. It's definitely a different vibe than earlier in the day and later in the day has been. But let's see, we got columns for that group, columns for that group. Then the idea is, say I've got a loop in which I'm doing BV table row, table select group, table import dir group. So I select that group and then I do table column, table kernel. Right, we got like module name, timestamp. Not column, these should be cell. So cell, timestamp, first forwarder. So that creates these. Now these are columns in a subloop here. So it would be something like select group, symbol group. And then cell, symbol name, symbol ordinal. We could add in some BV table row add link. So the link. So you add a link to the mark for that entire group, or that entire import directory. Okay, so the question now is, does this actually make sense? I'm trying to think this through a little bit, and I'm having trouble. Might be the kind of thing where I need to just dedicate a day to this particular topic. But what I'm trying to say is there needs to be a constructor API for tables that have this structure, this possibility. Now, the rules I'm assuming here are columns to the left are always taller than or the same height as columns to their right. Right, so this cell here is the same as this, is larger than any of these. So it's hierarchical. This mega row here contains these sub rows here. And in theory, that could go on further, right? If you wanted to subdivide, right? If this was sitting here and it had this structure because there was going to be two different ordinals for this particular, thing or whatever. This isn't actually possible in this case, but you could imagine putting these two as both equivalently sub to that, right? Having to declare these extra groups makes it a pain. But I need some way to tell it where the cell starts, right? So I guess another structure I could go for here in the constructor is I could do one of these. I could go, okay, boom, boom, for adding links, very good. And then what we'll do is we'll say, okay, push a cell, push a cell, push a cell, add a link to that row, and then BB table, let's simplify down one layer here. Push row or begin group or something like that. So then you're saying, okay, we made a row and we gave it these three cells and then we stopped. We said begin a group, and we created another row, and so here's a row with two cells. These two cells we know align with these columns because we're in a group where that group already has three cells in its parent row. So the children rows are filling in those last two cells only, right? And if you wanted groups and groups, you would just keep doing group begin. And now all you have to do is declare columns up front and keep them in order as you make sub rows. You do so by beginning and ending groups around them. I like that. That seems reasonable. So I think that's enough iteration today. This is a good plan, but I'm going to need to consider whether I want to do this today or as another pass. And I still haven't actually built that imports parser that I started on. So that's incomplete. And the question is, do I want to stop and redefine my table data structure first to make it more powerful and then put this in as an example? Or do I want to just finish this as a basic table for now and come back later? Probably the second option. And then do a round of iteration on table data structures later. But I think this will be good for now. With that, I'm going to wrap up for today. We've had a pretty good round of progress here. The new plugin is at least compiling. Started sketching out another part of the parser and running into new problems. Thought through some API design questions regarding pointer arithmetic and where we want to take our bets there. So I think this is a pretty good end to the week. If you are enjoying this project and you'd like to see more details about it as it's happening, remember that over at mrforth.com/membership, you can become a supporter or a member, and then you'll get the weekly dev logs. You might even get, if you check out some of these better, higher tiers, you get some other cool perks. So take a look at that and see if you want to support what I'm doing and learn more about what I'm doing as it's going on. With either way, though, thanks for checking out what I'm doing, and I will see y'all around the internet. Bye-bye.